This is Physics Lab 2 for Physics 2012, Larger Charge by Hershey Buddy. So I'll start off with an introduction of Physics Lab to prepare two pieces of charge tape and observe the interactions between them and create a program in glow script to calculate the charge of each piece of tape, assuming that the charge is spread out across the tape. And I found that the charge of tape is 9.46 coulombs and the magnitude of electric force of each tape out of each other is 2.16 newtons. So some fundamental physics principle is Newton's second law, which is that the net force just equals momentum over time. The gravitational force on Earth is mg, and the gravitational constant is 9.8 meters per second squared. And the electric force from Earth is include q times the electric field external, and also suggests that per point charge the force is equal to k times q1 q2 over r squared. And then the electric field of the uniformly charged rod formula is also important, as I'll explain later on. And that's the assumption is that r is significantly less than light. So going on to the experiment, so first I created two pieces of charge tape through the steps outlined on the slide. Then next I measured the length and width of a piece of charge tape and determined the masses of charge tapes. And I took one piece of charge tape and put it on top of books, and I put the other, I kept moving it closer to the other one until it started to move and float. And then once it started floating, I measured the distance. So what I got was that the width of the tape was 0.02 meters, the length of the tape was 0.22 meters, the mass of the tape was 0.22 times 10 to the power negative 3 kilograms. Distance between the tapes was 0.0038 meters. Now to find the charges on the piece of tapes. So to start off with, assumptions are just ignoring air resistance for an n. For the glow script model, I assume that the charge is uniformly distributed and I can model as many point charges. For the rod model, I assume that its charge is uniformly distributed, but I can model a tape as a rod. And then I assume that each tape has about the same amount of charge, evenly distributed, and the only external forces acting on tape B is gravity and electric force. So the system is just tape B, and its surroundings are tape A, the tape that was put close to tape B, and the tape B started to float, and the Earth. And then the initial condition to assume is that tape B is started at rest. And this is important because of this. We can see that F net is going to be Newton as well because there'll be no momentum change. So finding electric force, as you can see, the only two forces acting on tape B are the electric force and the gravitational force, which means that the electric force equals the gravitational force, which equals 2.15 times 10 to the power negative 3 newtons. They're just in opposite directions, but they have the same magnitude. So finding the electric charge in the rod model, first you can see that the radius is significantly less than the length, which means we can use the rod model for electric field. And from there we get the electric rod, we get equation for the electric field, and we can plug that in then to find the force equation which is just q times the external, and from there we can get charge is 9.99 times 10 to the power negative 9 coulombs. Now for the glow script model, here's a function to create the line charge in the first place. Then here's creating the top tape and bottom tape. As you can see, I used 33 point charges. And then what I did for each point charge would just be for each point charge within that piece of tape, I found its force on all the point charges in the other piece of tape, and I just summed up the total forces to get a total F net. And what I got, I kept doing that until I kept hitting the charge until I got a total F net for electric force net that was equal to the gravitational force, and the charge that did that was 9.461608 times 10 to the power negative 9 coulombs. So comparing the models, the rod model got a charge of 9.986 times e to the minus 9 coulombs, while model 2, which was the model using glow script, got 9.46. And it makes sense that the rod model had slightly higher charge because in the rod model it assumes completely distributed charges, which means that there'd be R would be bigger points, meaning a lower force, so there'd need to be a higher charge to compensate it compared to just using 33 point charges, which is what the glow script model used. And in source of error is just that I model the tape as a finite set of point charges in the glow script model, which is an error because in reality the tape doesn't just have 33 point charges, it's made of much more. And also the separation and the distance and mass were measured inaccurately, and the separation distance was kind of based on my eyes, and the mass was based on the estimate provided by the TAs. So in conclusion for the model, we determined the charge to be 9.46 times 10 to the power negative 9 coulombs, which is relatively close to the calculated charge using the typically a uniformly charged rod. Now, for the what if question, if you model each of the tapes as a single point charge, like in the previous lab, what would happen? And so in lab 1, when we did that, we got 1.86 times 10 to the power negative 9 coulombs, which is compared to the 9.46 times 10 to the power negative 9 coulombs I got in this model, which makes sense again with the same reason I said before for the model differences. With a point charge model, R is much smaller, which means you need a much less charge to get the same net force, compared to the line charge model where the R is going to be bigger because you get those points on the fringe of the line charge, which have a much larger R than what the center does. And then why do these estimates differ? Which value is more likely to be close to the real value and why? And the line charge model will just be more likely to be close to the real one because charges don't just cluster at one point as the point charge model assumes, because in the real world charges are uniformly distributed, or at least not distributed at one singular point, the more closely uniformly distributed. And with that, that's my lab. Thank you for listening. Bye-bye.